Hello friends, welcome to PRAYOGeek Uno channel. In this video, let's understand what is an AND gate and also how to use AND gate as a switch. Watch this video till the end as I'll be demonstrating practically how to use AND gate as a switch. So this is how an AND gate is represented. So as you can see here, AND gate has two inputs and one output. And this is the truth table for the AND gate. I guess most of you are already aware of the Boolean logic for the AND gate. So the simplest way to understand AND gate is just compare this with the regular switch which we use at our home to turn on a bulb. So let's assume A input is the 230 volts and this B input is the switch and Y output is nothing but the bulb which glows. Okay, so you know that for the bulb to glow we need to have the power which is the 230 volts and as well as we need to turn on the switch. So if we take this truth table, we can easily understand this truth table by comparing this to the switch. So in the first case, when A is 0 and B is 0, this means that there is no power and the switch is turned off. So the bulb will be off. And the second case is when A is 0 and B is 1. So this means that there is no 230 volts at the A input, which means even though you have turned on the switch, there is no power, which means the bulb will not glow, right? So the third option is A is 1 and B is 0 and output Y is 0. So this means that we have power at home but we have not turned on the switch. So this means that still the bulb does not glow. And the final option, for the bulb to glow, you need to have both power at home as well as you need to turn on the switch. So when both the inputs, so you have 230 volts power and also you turn on the switch, only then your bulb will be turned on. So this is how an AND logic works. I hope this example helped you to understand easily how to compare this AND logic with the regular day-to-day things what we do at home. So the question is, how do we exactly implement this particular AND logic? So the AND logic can be implemented in two ways. So the first one is we need to have a couple of transistors and few resistors. We'll not be dealing with this in this video, but just for an example I wanted to show you this. So the other method is using an integrated circuit, which is 7408. So the number 7408 stands for AND gate IC, and this is how an integrated circuit looks. So I'll be showing you practically how to make connections to the integrated circuit and also verify the truth table. So for now, let's have in mind that we have two ways of doing this. You can see here, this is how an integrated circuit looks. So if we use the transistor method of implementing the AND logic, then we need two transistors and few resistors, right? But let's say you want to use two or more AND gates. So then the number of components you need would again increase. So that's the reason we have an integrated circuit here. And the reason it's called an integrated circuit is we have 4 AND gates built into this single chip. And all the components which are required to implement the AND gate is already built into this chip. So that's the reason it's called an integrated chip. And this particular chip has 4 AND gates in it. So let's learn the internal block diagram of this particular IC and understand how to make different connections. So you can see here the IC 7408 has 14 pins, which is numbered from 1 to 7 on one side and 8 to 14 on the other side. As you can see, there are 4 AND gates built into this single IC, and each AND gate has 2 inputs and 1 output, and those inputs and outputs are assigned to different pins. So the first AND gate inputs are assigned to pin number 1 and 2, and the output is assigned to pin number 3. Similarly, for the second AND gate, pin number 4 and 5 are the 2 inputs and pin number 6 is the output. So you can see that each pin corresponds to inputs or outputs, and you need to know this diagram to know which are the inputs and which are the outputs. So apart from these inputs and outputs, the IC needs power supply. So for that we have pin number 14 which is connected to VCC and pin number 7 which is connected to ground. So if you want to work with this IC, we need to connect the power supply to pin number 14, which usually we connect 5 volts, and pin number 7 should be connected to ground. And then we can use whichever AND gate we want from these pins. Now let's look at the IC and try to understand how to identify the pin numbers. So you can see on the IC there is a notch here, right? So always the numbering starts from the left side of the notch. So you need to identify the notch on the IC, and from the left side it always starts with pin number 1, and then the numbering goes in anti-clockwise direction. So we have the notch here on 7408 IC, and on the left side this is pin number 1, and then it goes down 2, 3, 4, 5, 6, 7, and again 8 starts from here. This is pin number 8, 9, 10, 11, 12, 13, 14. So always the numbering goes in anti-clockwise direction, and it always starts from the left side of the notch. So please remember this. This is how you identify the pin numbers of the IC. So now once you are familiar with how to identify the pins, we can go ahead and make connections, and let's verify the truth table for AND gate. So we'll be using our PRAYOGeek Uno board and as well as the Android app to give all the inputs and see the outputs. So the first step is make sure that the IC is properly inserted inside the breadboard. Now if you look at the pin diagram of the IC, pin number 14 should be connected to VCC. So what I'm going to do is I'll connect a wire from pin number 14 to plus 5 volts in header number 4. So you can see that in header number 4 there is a pin for plus 5 volts. So I'm connecting this to pin number 14. So the next step is we need to connect ground, which is pin number 7. So I'm going to pin number 7 and connecting it to ground pin. So in header number 6, so you can see that in header number 6 in PRAYOGeek Uno board there are 2 ground pins, so you can connect to either one of them. So now once we are done with giving the 5 volt supply and the ground pin, the next step is we need to provide 2 inputs. So from the diagram you can see that pin number 1 and 2 are the 2 inputs. So in PRAYOGeek Uno board you can see that there are 2 headers at the bottom. The headers on the right side is the input headers. These can be connected to the input pins, and the header on the left side is the output header. So there are LEDs here which will show the output state. Let's go ahead and connect this first input header pin to pin number 1 and the next header pin to pin number 2. So this forms the 2 inputs for our AND gate. Now from pin number 3, which is the output of the AND gate, let's connect it to the output headers. So you can connect to any of these pins here, that's not a problem. On the Android app, we have 8 input buttons which are numbered from 1 to 8. So you can see it here. So you can actually turn on or off these buttons to give inputs to the AND gate. And since we have connected pin number 1 and 2 here to the input of the AND gate, let's verify the truth table according to these 2 inputs. So now the first one here is both the inputs are 0 and 0. On the Android app, you can see both pin number 1 and 2 are 0. So the output LED is also 0. Now the next input combination is 0 and 1. So what I have done is I have made this particular switch as 1, and you can see that still the LED is 0. And the next combination is 1 and 0. So now I change this combination as 1, 0, and you can see still the LED is off. Now when I make both these inputs as 1, then you can see the LED has turned on at the output. So this actually confirms the truth table of the AND gate. So here we just verified the first gate in this IC. Similarly, there are 3 more gates apart from this. So you can also connect to the other pins and verify these gates. So many of the times while doing experiments in your lab, what happens is you might not get the output, and all your connections might be correct and still the output might not be coming. So it's always a good practice that before you use any IC in your lab, you take that particular IC and verify if all the gates are working fine or not. So once the gates are working fine, you can make more complex connections in your lab and verify different circuits. So this is one of the way to debug your circuit. So if you are not getting output in the lab, make sure that the individual gates are working fine and then you go for bigger connections. Now let's look closer at this truth table and understand how we can use this AND gate as a switch. If you observe this particular part of the truth table, you can see that when one of the input is set at 1, then the output is nothing but same as the other input. So here the input A is 1, so the output is nothing but the value of B. So here if B is 0, then the output is 0, B is 1, then the output is 1. And if you look at this particular part of the truth table, so when you make this input as 0, so no matter what the input value is at the other pin, the output is always 0. So this can be used as a switch. So when you make this switch as 1, then the value of the other input just goes to the output, and when you make the switch value as 0, then the output is 0. So we can verify this by giving a square wave at the input terminal B and using the other input as a switch. So when we make this A input as 1, then we are going to get square wave at the output, and if we make the input A as 0, then the square wave should disappear from the output. So let's make this connection and see how this circuit is going to work. I'm going to just remove one of the input pin, which is pin number 2, and connect it to pin CLK. So in header number 2, you can see that there is a pin called CLK. So that provides a clock input, and instead of connecting the output to the LED pin, I'm going to connect it to the digital oscilloscope, so which is pin DG1. So you can see here in header number 3, there is a pin called DG1, that is the digital oscilloscope pin. So you can see on the Android app, now let me decrease the frequency here. So now the frequency is around 500 Hertz. So you can see a square wave coming at the output of the AND gate. So this particular square wave is coming at the output because I have this input switch here as 1. So the switch number 1, I have enabled this. That's the reason I am getting the square wave at the output. Now as soon as I make this as 0, so you can see here I have made this switch as 0, the square wave disappears. So now once I make this as 1, the square wave comes to the output. So this way we can actually use AND gate as a switch. So basically what's happening here is we are making this particular input as 1, and the square wave whatever is there at the other input is coming to the output. So this is how you can connect AND gate as a switch and use it in some practical applications. I hope you got a good idea about how to verify the truth table of AND gate and also how to use AND gate as a switch. So in this example, we just took a 2-input AND gate. So similarly, we also can have 3-input AND gate or 4-input AND gate, depends on different applications. So if you felt this was informative, don't forget to like the video and subscribe to our channel. Let's continue to learn electronics in a practical way. Thank you for watching the video.